Hello students, today you are welcome to today's class. We will be discussing a very important topic. We have been discussing the same topic, but in the one we are having on the board, it involves application of partial fraction and is the solution to differential equation by the application of separation of variables. Now let's listen attentively. It's a very simple topic. Now the first thing to do is to cross multiply because we want to carry out separation of variables. We're having dy over dx equals y squared minus 1 over x. That's the equation. You cross multiply. I want my y, expression for y and dy to be at the left hand side, and my expression for x and dx to be at the right hand side. Now, I will now make sure that I have x dy, x multiplied by dy, that's x dy, equals y squared minus 1 dx multiply y squared minus 1. The next thing to do is to remove y squared minus 1 from the right hand side and bring it to the left hand side. What will I do to get that? I will have to divide both sides by y squared minus 1. The reason why I need to divide is because it's multiplication that we have here together. Okay, y squared minus 1 is multiplying the x. That's why I need to divide. But if it is addition, let me say y squared minus 1 plus something else, plus another expression, you take it across. Is that okay? Not by dividing. But now it's multiplication, you divide both sides. Divide both sides by y squared minus 1. And now I have x dy over y squared minus 1 equals y squared minus 1 dx over y squared minus 1. It cancel out. Automatically, you are left with x dy over y squared minus 1 equals to dx. Equals to dx. Equals to dx. If you look at what you're having at the left hand side, see that you're having x here, x dy. We have to remove x from the left hand side so that it goes to the right hand side. Okay? Now divide both sides by x. Now x dy over x, so this statement y squared minus 1 equals dx over x. X cancel x. We're left with, there's 1 at the front. Let me separate it, 1 over y squared minus 1 dy equals 1 over x dx. Try to make some separation. Now, don't forget that y squared minus 1 is an expression for difference of two squares, which can still be written as y squared minus 1 squared. And that y squared minus 1 squared is written as y minus 1 y plus 1. If you multiply this expression together, you still have this y squared minus 1 squared back. Let's see together. Y times y squared, y times plus 1 plus y, minus 1 times y minus y, minus 1 times plus 1, that's minus 1. Plus y cancel minus y, and left y squared minus 1, which is what we have here. 1 squared is also 1. Now, let's now go back. Instead of writing y squared minus 1. I will now write this expression to replace it because I want to carry out partial fraction method to solve it. I want to use partial fraction method to solve it. Now I have 1 over, instead of writing y squared minus 1, I'll now write this expression y minus 1, y plus 1. Close the bracket, dy equals to 1 over x dx. Okay, now since you have it like that, you can now integrate both sides. Integrate both sides. Now write integral of 1 over y minus 1 y plus 1 dy equals to integral of 1 over x dx. Now let's solve left hand side with the application of partial fraction. Okay, multiply partial fraction method. Now have integral of 1 over y minus 1 y plus 1 dy equals integral of a over y minus 1 plus b over y plus 1 dy. Now let's express this. We're still going to equate the numerator to the numerator of what you have here. But let's solve this one first. What you have here. Now integral of a over y minus 1 plus b over y plus 1 dy equals, what's the LCM? Take y minus 1 and y plus 1 as the LCM. Okay, dy. Now let's see, y minus 1 goes in y minus 1. We pick y plus 1 to multiply a into y plus 1 plus b, open bracket, y plus 1 cancel y plus 1, use y minus 1 to multiply b, y plus 1. Okay, what you now do now is that you now go back this expression for what you have at the left hand side. You now equate the numerator to the numerator you have in at the right hand side. Now 1 equals a y plus 1. So this cancel this, you are writing y minus 1 here. Let's get it right. Minus y minus 1 cancel y minus 1, use y plus 1. Y plus 1 cancel y plus 1, use y minus 1 to multiply b. Plus b into y minus 1. Okay. Now let's solve it. When y equals to 1, let's know what we have. 1 equals a into 1 plus 1 plus b into 1 minus 1. 1 equals 1 plus 1, that's 2. 2a plus b into 0. 1 equals to 2a. Now what you do now is that you divide both sides by 2. 1 equals to 2a, that's what we have. Divide both sides by 2. We're having 1 divided by 2 equals to 2a divided by 2. 2 cancel 2. Therefore, our a equals half. Our a equals half. Now, let's see when y equals minus 1. When y equals to minus 1, we substitute back in this expression. 1 equals a into minus 1 plus 1 plus b into minus 1 minus 1. You can see your y is minus 1. 1 equals a into minus 1 plus 1, that is 0, plus b into minus 1 minus 1, that is minus 2. You have 1 equals minus 2b. Divide both sides by minus 2. Divide both sides by minus 2. You have 1 divided by 2 equals minus 2b divided by minus 2. Minus 2 cancel minus 2. Now, your b, this is my divide minus 2, your b equals minus 1 over 2. Okay? Now, you now go back and substitute back your expression into what you have here at the left hand side. Integral of 1 over y minus 1, close the bracket, y plus 1 dy equals integral. What's our a? Our a is half over y minus 1 y minus 1 plus b. What's our b? Minus half over y plus 1 dy. Now don't forget that when you are solving this fraction, 1 over 2 divided by y, they are together. This 1 over 2, they are together. By y minus 1. It will now be 1 over 2 divided by y minus 1 over 1. When you are doing changing division to multiplication, the denominator will go to the numerator and numerator come to the denominator. You have equals 1 over 2 times 1 over y minus 1, which is half y minus 1. Okay? The 2 will come down. So will come down. Now, since you have this expression, it's now equals to integral of 1 over 2 y minus 1. What's the negative give us negative minus 1 over 2 y plus 1. Close the bracket. Dy. Now you now equate it to the expression at the right hand side. Equate it to the expression at the right hand side, which is now integral of 1 over 2 y minus 1 minus 1 over 2 y plus 1 dy equals integral of 1 over x dx. Now 1 over 2 is common to both fractions. Bring it outside the integral. 1 over 2 into 1 over y minus 1 minus 1 over y plus 1 dy equals to integral of 1 over x dx. Now, you now have your expression to be half into the integral of 1 over y minus 1 is equal to ln y minus 1. Now say half into ln y minus 1 minus ln y plus 1, close the brackets, equals to ln x plus c. Always add the constant to the right hand side. Always add the constant to the right hand side. And they always know that when you differentiate the denominator of what the lane you are taking, when you differentiate the denominator, you must get the numerator. Differentiate y, you have 1. Differentiate constant 1, you have a 0. Differentiate y, you have 1. Differentiate this constant, you have a 0. But the integral of 1 over y minus 1 equals to ln y minus 1. That's why you have ln y minus 1 to represent the integral of 1 over y minus 1. And you now have 1 over 2, open bracket. When you are taking one lane, you change this negative to division. That's the indices. All right, lane. This line will cover both y minus 1 and y plus 1 because it's representing both y minus 1 over y plus 1 equals to ln x plus c. I want to remove these two, multiply through by 2, so that these two will cancel out. Now 2 times 1 over 2 ln y minus 1 over y plus 1 equals to 2 ln x plus c. You don't need to multiply this constant with 2 because it's a constant. It's not necessary. Now 2 cancel these 2. You're having ln y minus 1 over y plus 1 to be equals to 2 ln x plus c. Now let's want all the expression to be in terms of ln. And that's where, let's assume that where c equals to ln c. Where c equals to ln c. Of ln y minus 1 over y plus 1 equals to 2 ln x plus ln c. Now ln y minus 1 over y plus 1 equals to, take 2 to the front, become ln x squared plus ln c. In indices, when you are using ln to represent the two expressions, it turn to the multiplication addition turn to multiplication. Addition turn to multiplication. We are using ln to represent the two expressions. ln y minus 1 over y plus 1 equals to ln c x squared. Okay, this ln cancel this ln. We are left with y minus 1 over y plus 1 equals to cx squared. This is the end of the class. Thanks for watching. Please don't forget to send your question to the comment section. Have a wonderful day.